The global macroeconomic reality of 2026 is defined by a definitive transition. Hyper-globalized, cost-optimized supply chains are fracturing, replaced by vertical ecosystems organized strictly around the principle of technological sovereignty. This exposes a stark divergence in the industrial trajectories of Asia's two largest powers. China has spent the past 2 decades building a state-directed, investment-heavy engine of hard tech manufacturing. India's economic expansion has relied heavily on domestic private consumption and software-enabled services. India possesses a formidable digital public infrastructure and a deep pool of STEM talent. Yet a severe innovation deficit persists in tangible, heavy industry deep technology. Global economic power is no longer measured by aggregate consumer demand. If a nation cannot physically manufacture the foundational infrastructure required to sustain its population, its software prowess offers zero structural protection. This horizontal axis illustrates the supply chain. The far left upstream layer engineers deep tech research, advanced materials, and precursor chemicals. The far right downstream layer governs consumer assembly and software. Plotting corporations reveals Chinese monoliths dominating upstream, while Indian conglomerates crowd downstream, leaving a massive upstream void. Operating exclusively at the downstream integration layer creates an illusion of economic independence. In practice, it leaves the domestic market highly dependent on geopolitical rivals for its most basic foundational inputs. This chart compares India's massive global generic volume against its market valuation. The high bar reflects India producing 20% of the global supply of generic drugs, earning it the title Pharmacy of the World. The low bar shows its distant 14th place ranking in global pharmaceutical valuation. This is the volume-value paradox. Indian pharmaceutical value is largely derived from off-patent process engineering, finding cheaper ways to manufacture existing molecules. It captures a fraction of the value generated by product intellectual property, which involves discovering novel drugs. China has systematically pivoted away from low-margin generic manufacturing. Backed by intense state funding, highly capitalized entities like Wuxi AppTec focus on novel drug discovery and high-value biologics. Behind India's global export success in finished generic medicines lies an entrenched dependency. India imports up to 70%. While Indian firms excel in generic agrochemical distribution, the Chinese state spent $43 billion acquiring Syngenta to internalize world-class biotechnology and proprietary seed genetics directly into its state apparatus. This biological vacuum is compounded by a physical hardware gap. True precision farming requires heavy payload, autonomous mechatronics to apply complex agrochemicals at scale. India currently lacks this domestic manufacturing capability. Indian agritech startups deploy lightweight drones for mapping and entry-level spraying. They have yet to match vertically integrated near monopolies like the DJI Agris, which utilizes proprietary coaxial twin rotors to carry massive 50-kilogram payloads. Agricultural and healthcare sovereignty cannot exist when the foundational biogenetics, chemical precursors, and precision hardware are entirely engineered and controlled by a foreign power. India reached its target of 50% non-fossil electricity capacity 5 years ahead of schedule. Domestic companies capitalized on this by rapidly expanding their downstream manufacturing, scaling solar module assembly capacity past 90 gigawatts. But a finished solar module is just the final assembly step. The supply chain requires 4 distinct upstream layers: photovoltaic cells, sliced silicon wafers, cast ingots, and highly purified raw polysilicon. Chinese manufacturers exercise complete dominance across these nodes. They produce 93.2% of the world's polysilicon, 96.6% of its silicon wafers, and 92.3% of its PV cells. Until recently, India possessed virtually zero commercial capacity for ingots or wafers. The gap extends well past pure production volume into deep tech research. Chinese leaders are transitioning away from standard architectures toward ultra-high-efficiency TOPCon and back contact cell designs. TOPCon utilizes ultra-thin oxide layers to minimize electron recombination and boost energy yield. These giants are also engineering out supply chain bottlenecks. They have initiated mass production processes that replace highly expensive silver with electroplated copper inside the cells, securing an insurmountable cost advantage. Unless India develops domestic upstream fabrication plants and circular material recovery smelters, its heavily subsidized green energy transition will effectively function as a multi-billion-dollar wealth transfer to Chinese polysilicon monopolies. The technological vacuums across these sectors are not caused by a lack of engineering talent. The physical hardware deficits are the mathematical outputs of systemic structural bottlenecks. This diagram compares the first critical bottleneck, gross domestic expenditure on R&D, or GERD. By 2024, China deployed approximately $785 billion into state-led research. India's expenditure remains structurally suppressed at roughly $75 billion. In China, state-owned enterprises act as the ultimate venture capitalists. They provide artificially low borrowing costs, absorbing the immense financial risk and sustaining the massive losses required for fundamental scientific discovery. The second bottleneck is the fundamental cost of capital and the venture risk appetite within the Indian ecosystem. Synthesizing a novel chemical ingredient or scaling a polysilicon plant requires patient capital. It involves exceptional upfront expenditure and a 10 to 15-year gestation period. Indian venture capital is largely driven by foreign limited partners, seeking rapid 5 to 7-year exit timelines. The statistical result is acute. 91% of deep tech funding in India is funneled into software and artificial intelligence, leaving physical advanced manufacturing starved of critical scale-up capital. India's hardware deficit is a mathematical certainty. Domestic capital markets are structured to demand software-like returns from capital-intensive heavy industry realities. Moving to the built environment and urban infrastructure reveals a final, uniquely Indian structural bottleneck actively preventing hardware modernization. This is the labor arbitrage trap. In sectors requiring physical manipulation of the environment, the sheer abundance of incredibly cheap, unorganized labor acts as an active disincentive to industrial modernization. Chinese construction giants have completely industrialized civil engineering. They rely on factory-built volumetric modular architecture and deploy comprehensive suites of smart structural robotics. The Indian construction industry remains trapped in an economic equilibrium heavily reliant on manual labor. Workers still physically pour concrete and bend rebar by hand across sites nationwide. The economic calculus of an Indian developer optimizes for the immediate short term. Massive capital expenditure required for automated robotic systems fails return on investment thresholds. Consequently, the deployment of automated bricklaying robots or 3D concrete printing is continually deferred. By optimizing for cheap labor today, India stunts its domestic robotics industry. When domestic labor costs inevitably rise, the nation will lack indigenous intellectual property and be forced to import automation hardware directly from China. These massive structural vacuums present highly lucrative, impact-driven opportunities. For a new generation of Indian B2B enterprises, these deficits act as a precise strategic roadmap. Returning to the axis, the empty upstream void shows exactly where enterprises must attack. Targets include continuous chemical synthesis for key starting materials, circular recovery for solar waste, and autonomous mechatronics for agriculture. This expands into a gap matrix, cross-referencing sectors against precise technological vacuums. Startups must abandon crowded, low-margin consumer software markets. Focusing strictly on these upstream physical choke points secures high margins while directly contributing to national supply chain resilience. The Republic of India stands at a critical macroeconomic precipice. The global order is fracturing into competing technological blocks. Bridging the deficit requires a national pivot. Venture capital and state funding must redirect away from hyper-convenience consumer applications and aggressively co-invest in physical, foundational sciences like advanced metallurgy and chiral chemistry. India's transition from an economy of massive consumption to a self-reliant global superpower depends entirely on its willingness to embrace the arduous, capital-intensive realities of deep tech manufacturing. True technological sovereignty in the 21st century cannot be outsourced. It must be engineered, funded, and physically